Hello everyone. In the previous videos, we have seen the definition of a variable, the types of variables as quantitative and qualitative, and the classification of the quantitative variables as discrete and continuous, and the classification of the qualitative variables as binary and multinomial. In addition, we have seen that the four different scales of measurement, which are nominal, ordinal, interval, and ratio. And there is also another criteria for classifying variables, which is the role of the variables in the statistical analysis. So today we are going to cover the role of the variables in the statistical analysis. So based on the role of variables in a particular statistical analysis, a variable can be classified as a dependent variable or it can be classified as an independent variable. A dependent variable is a variable that is of primary interest to be determined as an outcome. For example, if we are interested on the outcome of a certain treatment, whether the treatment is effective or not, so this variable can be considered as a dependent variable. The educational achievement level can also be considered as a dependent variable because it is a variable that is of primary interest to be determined as an outcome. And usually for the term dependent, we use the term outcome and response interchangeably. So a dependent variable is nothing but it's an outcome variable or a response variable. So throughout this tutorial, I may use the term dependent, outcome, and response interchangeably. Therefore, all of these three terms mean the same thing. And an independent variable is a variable to be used to determine the dependent variable. For example, sex, age, type of treatment can be considered as independent variables. And usually, an independent variable is called a factor, an exposure, a predictor, or a covariate. So like that of the synonym terms for dependent, which are outcome and response, the synonym terms for independent variable are factor, exposure, predictor, and covariate. So we can use the terms factors, exposures, predictors, covariates, and independent variables interchangeably. Therefore, this is the main classification of variables based on the role of the variables in the statistical analysis. In a simple terms, we can consider the independent variable as an input and the dependent variable as an output. Therefore, the change in the independent variable affects the value of the dependent variable, or the input affects the value of the dependent variable. So an independent variable can be considered as an input and a dependent variable can be considered as an output. Let's consider these examples to identify the dependent and independent variables if these are the objectives of a certain study. If we say the effect of sex on blood pressure, now here sex is the independent variable or the factor, blood pressure is the dependent variable. Similarly, if we consider the effect of age on hypertension, age is the independent variable, hypertension is that of the dependent variable. The same is true for that of the effect of sex on hypertension. Let's consider number 4, comparing the number of sexual partners between urban and rural resident women. Now here, the dependent variable is number of sexual partners and the independent variable is residence. Then residence takes values urban and rural. Therefore, the independent variable is residence with values urban and rural, and the dependent variable or the outcome variable is number of sexual partners. And let's consider number 5, investigating the effectiveness of a new therapy compared to the traditional treatment. Now here, the effectiveness of the treatment is the outcome variable. It may be effective or not. And the type of the treatment is the independent variable. The type of the treatment could be the new therapy or it could be the traditional one. Therefore, here, the type of treatment, whether it is new therapy or traditional, is the independent variable, and the effectiveness of the treatment is the outcome or the dependent variable. Similarly, if we consider evaluating the effect of different fertilizers on crop yields, the crop yield is a dependent variable, and the fertilizer type is going to be considered as an independent variable. Comparing the blood pressure of male and female individuals. Now here the dependent variable is blood pressure and the independent variable is sex with categories male and female. So here number 1 and number 7 are exactly the same, but the way that the objectives are expressed is different. Otherwise, number 1 and number 7 are the same. In both cases, the dependent variable is blood pressure, the independent variable is sex with categories male and female. Studying the effect of a new teaching method on student performance. Now here, the student performance is going to be considered as a dependent variable, and the teaching method is going to be considered as independent variable. So the teaching method could be new teaching method and the traditional one. The effect of age classified as 18 up to 24, 25 up to 34, and greater than 35 years on hypertension is the same. Hypertension is the dependent variable, age is the independent variable. Now let's consider that of the independent variables or the factors or exposures or predictors or what we call covariates. Now there are two types of covariates or two types of independent variables. One is called attribute or measured, and the other is called active or manipulated. An attribute factor or in an attribute independent variable, the values are pre-existing characteristics of objects under study. So in an attribute independent variable, the values cannot be systematically changed or manipulated. They are just pre-existing characteristics of the objects. For example, you can consider education, sex, socioeconomic status. These variables represent pre-existing characteristics of a certain individuals or let's say in general objects. Therefore, these type of independent variables are called attribute independent variables or attribute factor variables. On the other hand, we could have an active independent variable. In the case of active independent variable, now the values of these variables can be experimentally manipulated. So such an active independent variable is a necessary but not sufficient condition to make cause and effect conclusions. Therefore, an active independent variable is essential for making cause and effect conclusions, but is not sufficient. It's necessary, but is not a sufficient condition. For example, if a researcher might investigate a new therapy compared to the traditional treatment, then in this case, the treatments can be randomly assigned to the individuals. That means the treatment values are being manipulated. Therefore, here treatment type can be considered as an active independent variable. And another example, for example, if you consider the effect of different fertilizers on crop yields. Now, the different fertilizers may be randomly assigned to different plots. Therefore, the values of the type of fertilizer is being manipulated. So, type of fertilizer can be considered as an active independent variable. So, most of the time, studies with active independent variables are utilized in experimental studies in biological, chemical, and that's of in agricultural studies. Therefore, these are the two classification of predictors or covariates or independent variables, whether the values can be manipulated or not. Those independent variables whose values cannot be manipulated are called an attribute independent variable, and those variables whose values can be manipulated are called active independent variables. In general, a statistical analysis doesn't differentiate whether a factor or an independent variable is an attribute or an active, but it is the responsibility of the researcher to identify whether the factor is attribute or active, because there is a crucial difference in the interpretation. If we have an active independent variable, then we can infer that the independent variable or the factor variable caused the change or the difference in the dependent variable. On the other hand, if we have an attribute independent variable, then in this case we cannot lead to conclude that the attributes independent variable caused the change in the dependent variable. Therefore, when we have an active independent variable, that means we can establish cause and effect relationships. But if we have an attribute independent variable, there may be a relationship between the independent and the dependent variable, but we cannot establish cause and effect relationships.